The point of cross-site scripting is primarily to attack clients, and it's primarily for one user to attack another, although it can be used in other ways. So if you are able to perform a cross-site scripting attack, you can then cause a browser to run code that was not put there by the developer and was not put there by the user, but a third-party sneaks code on the page. So anything JavaScript can do can happen, and JavaScript can do a lot. It can't do everything. It can't like reformat your hard drive or something, but it can do quite a bit. It can do pretty much anything the browser could do. So it can keylog key presses you make while the browser is active, and steal cookies and things like that. And if you actually have a browser vulnerability, and those come around, they used to be much more prevalent in the things like Java and Flash, then you could, in fact, even run operating system commands, reformat the hard drive, install rootkits, and all that jazz through the browser. This is the most common web application vulnerability in the world. I've heard estimates that like 80% of all websites have cross-site scripting vulnerabilities. You can't get any bounty from anybody if you report them. They won't even fix it if you report them. There's a bunch of websites where you just list everybody with XSS. Everybody's got it. Nobody cares at all. They usually don't. They don't regard it as their problem because it doesn't mean you can get in the server and steal the data from the server or compromise the server or deface the web page or anything. It's just you guys are abusing each other, the customers, and the companies mostly think that's not their problem and they don't care. And therefore, although in itself it is relatively low impact, it can be combined with other things and turn into a high impact attack. So the three main categories are reflected, stored, and DOM-based, which is kind of a strange mixture of the two. Reflected is the most common and the simplest, where you have something like a page where you put in a query string, and then the next page says, I'm looking for shoes. The next page says results for shoes. So something I put in appears on the next page, and if they don't filter it, then I can put script in, and the script will bounce back on the next page. And that means I can have script run on my machine, and that means I can craft a crafted URL that contains that query and email it to someone, and when they click on that link, it will put the script tag in and run on their machine. So if I can trick people into visiting a malicious site, I can run script on their machine. So let me get my demos up. I got a bunch of these. We'll go here now and then. Yeah, here's my page of XSS demos. So we've done some of these already. Yeah, the simple one is reflected XSS. We've done this before. So the message is developer was drunk, and I got to put burp in the front to make it fast, I've discovered. All right, so now it says developer was drunk. So if I say in this, in there, then it pops up a box. And this is the classic thing you do. That means it's running an alert box. If you try to do this in Chrome, Chrome will block the alert box. Because browsers, just like HTTP logins, browsers are choosing to fix this problem. Sites have not shown much interest in removing this problem, so browsers are starting to fix it. So when they get a payload that looks like XSS, they'll block it. But not Firefox. Not as vigorously as Chrome yet, anyway. So in a reflected SSS, that's what I say, the user logs into something. This is how you get into somebody's account by stealing their cookie. User logs into something, and now they have a cookie, so the attacker gets to hijack your session by feeding you a crafted URL. So you log into Facebook, and then I send you an IM, say, hey, look at my funny picture of a cat, and it's a Facebook link. And when you click that Facebook link, it goes to what it thinks is a Facebook page, but it has script from me, which takes a copy of your Facebook cookie and sends it to me. So now I have your Facebook cookie and I'm getting your Facebook session. That's how it works. That is the classic attack. User logs in as normal, they get a cookie, this is their session ID. Now I somehow feed them a URL that now includes script, new image, source is my attacker, and document cookie, so it will try to resolve an image tag, and in the name of the image it's fetching will be the cookie. So all I have to do is look at my server logs and see what image did this guy try to load, and I'll find the cookie on there. That's one of many ways to send a value up to a server. And once I have your cookie, of course, I can be in your session. Unless the developer actually implemented anti-CSRF methods, which they certainly could, which would have something like a hidden field on the page, or to use your IP address or something, and it has to be combined with the cookie, so the same cookie in a different browser on a different machine will not be accepted. Almost nobody does that, but it's really quite easy to do. This long number could include like a hash with your IP address, so that it can only be used on that one machine. And that would be just fine because the user doesn't copy the cookie from this to their phone. They actually log in on their phone with their password. It could very well be a different cookie on their phone than on their browser for their session, and it should be. They would never know or care, but it really matters to the attacker who's stealing the cookie. So that's the game. All right. Then this is the problem with persistent cookies. If you have Remember Me, or I think it's not in the book, but I found this out doing my own research for about half the sites on the internet I've tested up, maybe a few hundred, you don't even have to have the Remember Me functionality. Just the normal session cookie works forever. When you log out, it does not invalidate the cookie. I can take the stolen cookie and get in forever. I can do that at Amazon and many other sites. So the same origin policy is some attempt to prevent this. The browser knows what domain you're at by looking at the URL, and it will only send cookies to the domain that set the cookie. So evil.com, if you go there, will not get your target.com cookies. That's the game. That should be target. Anyway, right, but if I have cross-site scripting, then I can add script to a page that's on the target domain, and that script can get the cookie, and that's the game. That's why it's cross-site. I take a script that was not written by the target developers and is not present on the target server, but it runs in your browser, and your browser thinks it came from the target server. That's why it's cross-site. I trick your browser into misunderstanding where this came from, and therefore misapplying the same origin policy. So that's the game. Then there's stored XSS vulnerabilities, where I have something like eBay, where you can put up a picture of something and sell it, and you can put a description, and if I can put script tags in the description, then I can put up a malicious posting, and everybody that views it will now all be affected. I could be stealing their token or making them buy my product or something. I could execute anything that's happening in their browser just from them viewing the page. So one attack affects many viewers. And so we've done that before, this vulnerable message board. You put things up and everybody that views it will see the message. So that's all there. Now the third one here is a strange sort of mixture of these, and the trick here is if you have a page where part of the URL is used to construct the body of the page, like part of a folder name or something, is then put on the page, then I can add script to the page that did not come from the server at all. I make a malicious link which has script in the link, which then goes in the URL bar of the browser and onto the page without coming from the server. But again, your browser interprets it as having come from the server, and it defeats the same origin policy. This is not that common, but it does happen now and then. So here's a dynamically generated error message where you have a URL, and it puts here the message on the page which came from the URL. So if I put script in the message, in the tag you click, I put script in the URL, it appears in your browser thinks it came from the server, but it didn't come from the server. Server had nothing to do with it. So it's just yet another way of the same thing. Your browser runs the script thinking it came from the server, but it didn't really. This is where you get really sort of the fundamental logical problem here. The same origin policy, I think it might be fair to say it dates from the old innocent age when the internet was simple and you would request from one page like yahoo.com and you would get data just from yahoo.com. But that's not the way it is at all anymore. You're going to get advertisers and junk coming from everywhere, and your browser extensions and your password form fillers, and that data just coming from all over the place. So your browser pretending that this all belongs to yahoo.com is kind of far too simple to deal with the real complexity of what's happening here. And so that's the fundamental problem. It's just like having discretionary access control, where if you have a laptop, you can just do anything with the data on your laptop. And now, if you have clients and you have a government job and military secrets, and there's one laptop that you have complete control over, your security model is too simple to handle the real complexity of what's going on here. Your corporate data should somehow be separated from the military secret data and somehow separated from your personal private information, and not all just put on one device with one simple rule, like your browser with one simple rule, the same origin policy. All this stuff belongs to Facebook, which it doesn't really. So I made a page that does DOM-based XSS here in example number 4. So here's a URL with a message containing hi. And when you open that one, it uses this script on the page, so it puts it on the screen. So this hi from the URL appears on the screen there. It didn't come from the server, but the browser interprets it as somehow associated with the samsclass.info domain. So I could steal your samsclass.info cookie, or I could run scripts, and the usual script you run is this one. The fact that that popped up saying hi means I could run anything JavaScript can do. And the browser will execute it within the context of thinking it's at the samclass.info domain. So if you have a cross-site scripting vulnerability, and this is one of the many types, then attackers can exploit customers' browsers bypassing the same origin policy. All right. So I got a few cahoots about that. So what's the most prevalent web app vulnerability? I didn't put this in the cahoots, but I could have. Which one is the OAuth's #1 in the top 10? SQL injection. Yeah, it's not the most common, but it is the most important because the damage is so much more. And that's why everybody has cross-site scripting, but that's because they don't really care because it doesn't do anything like that much damage. Anyway, all right, so that's XSS. All right, so in a search page, script in the query string runs on the result page. What's that? Okay, that is reflected XSS. You sent the data up and it bounced back to you. That's reflected. It's not stored anywhere. You can bounce an attack off the server and hit somebody. That's how it works. Then the server gets blamed for it. All right, which one can steal session cookies? All right, any of them can steal session cookies. They all have a similar effect. And like I say, there are simple mitigations that would greatly lower the harm of this. If when you logged out the cookie quit working, that would help. If you just had an anti-CSRF parameter elsewhere on the page, so the cookie won't work on another browser, that would help you enormously. Then stealing the cookie wouldn't really do any good. But very few people do it. Anyway, which attack steals all the data in the database? None of them. The only thing that does that is SQL injection. That's why I say this is considered a low priority vulnerability for that reason. It doesn't do that kind of horrible stuff. So it's match.
Get an admin account and then take the database.
Yeah, but you're not going to get the admin account from XSS, not easily. You might be able to. It did happen to Apache. So yes, XSS can be used as part of a chain of attacks that eventually get you the data, but SQL gets you right to the database right away. Yes. So you're right. And that's why some people have said this rating of vulnerabilities is unwise, and you should just say every vuln is a vuln and fix them all. Other people, and the jury is still out. There's a whole discipline where people try to define security metrics and say how much you'd like to rate your firewalls, your applications, your people, your servers as a 1 to a 10. How strong is the people? How strong is this firewall? How bad is this vuln? So we can figure out how many dollars per year we'll lose from getting hacked by having a 7. And for $1 million, we could have an 8. That would save us this much money. Everybody would like to have that, and we're just nowhere near it. Yeah. And I mean, one of the nastiest things is Rapid7 scanned the whole internet, and they found that like 90% of all attacks used the same 10 vulnerabilities, all of which were patched like 5 years ago. So putting on the latest patch is arguably not very important at all. It's a problem. We do all this stuff that seems like a good idea, but we can't really prove that we're saving the company money by doing this stuff. It's an art, not a science. Yeah. We do what seems good, and we're convinced by other people in the field that this is the current tradition to do it this way. We cannot really have good science about the best way to do it. So here's a few real-world attacks. The one you mentioned, running on administrative rights. Apache had a code injection vulnerability on the issue track where you could submit bug reports. And the bug reports are, of course, viewed by the Apache developers, so they managed to steal the session cookie from the developer and become the administrator, and then they could go put poison versions of Apache up there for people to download. This also happened to Mint about 3 years ago. Mint, somebody hacked the main server and replaced Mint with a poison version of Mint, and Mint's official response the next week was, it's fine because we put up an MD5 hash to make it safe. And I'm like, that right there gives you a clue how far behind the curve Mint is. But anyway, because as you know, the MD5 hash doesn't prove much of anything at all. It's pretty easy to forge an MD5 hash. So the attacker was able to capture usernames and passwords from privileged users, and eventually got on and compromised the system. Not cookies, but he stole usernames and passwords directly. MySpace, this was what made Sammy Kamkar famous. I don't quite know where he's from, but he did this. It was I'm sure it was illegal, although the laws were in a more primitive state then, but MySpace was big at this time before Facebook, and he put a script on his profile so everybody that viewed his page would run the script, which would add him as their friend and put the script on their profile. So everybody that viewed their profile would now add him as a friend, and in like an hour he was the most popular guy on MySpace with like 10 million friends. It was a cute attack, and it was educational to all of us. It was one of these things like the I love you worm, and we all said, how did that work? We all learned a lot from it. Most of us didn't have any clue about code injection and cross-site scripting, and this was the proof of concept that this was awesome. And I don't think he got prosecuted. I think he got some degree of legal trouble, but they didn't actually lock him up or anything. What's that?
He's fined $20,000.
$20,000. Oh, that's rude.
Yeah. Could only use one computer for like 3 years.
Oh boy, that's pretty harsh. Okay. Yeah. So anyway, but now he's out again, and this made him famous, and he's got his own YouTube channel and his own demonstration attacks, and he's still out there, being a more or less successful professional. But yeah. Anyway, this one was pretty good. This was the first guy to have two-factor authentication on his email, and he was so proud of it. He said, "I'll give you $10,000 if you can hack me." So they hacked him with cross-site scripting. Now, they found a cross-site scripting vulnerability in his website, and they embedded the payload in a PDF file, and they emailed it to him saying, "We want the $10,000 bounty. The attached PDF proves that we've won." And when he opened the PDF, it ran the script and stole his cookie. And they had played with the app and found out that although it's two-factor authentication, it sends a text to your phone, you can click a box and say, "Don't send me a text when I log in from my trusted computer." So they knew he would do this on his trusted computer, and they got his trusted computer cookie. And again, he didn't bother to have anti-CSRF defenses on his trusted cookie, which he wasn't called that clever. They were able to get in. So that's pretty cute. Yeah. Social engineering and XSS together.
Did they get the $10,000?
Well, I think he tried to weasel out of it, but I think the judgment of the community was within the next week that they deserved it. I don't really know if they actually paid. This is the same time period when there was a guy that ran one of these services when you get hacked to protect your credit card number, and he actually put his social security number on the side of his panel van and on the internet and everywhere saying, "It'll be fine, my account is protected," and he got hacked so bad they made like 10 fake credit cards and stole all this money. He learned that his own service was pretty worthless. That's what people told me. This credit protection service you get is pretty much just nonsense. They can't really do much. Anyway, Twitter got slammed by cross-site scripting. I remember a bunch of these. I saw a bunch of these spread around. This one started from a 17-year-old. So it would post messages that had you go to some page, and when you went to that page, there was an attack, and this worm would spread around on Twitter. I remember there's one where you would see the tweet, and you'd automatically be retweeting it to everybody. Kind of like the Sammy worm, but simpler. There have been a variety of them. One of the most recent ones, like a month ago, there was a Unicode string that would freeze your Safari and crash your iPhone or something. Yeah. And so everybody was tweeting that around for a while before Twitter wised up and blocked it. Did you get hit by that?
No, but my friends were messing around with it a lot.
I knew my friends from Microsoft about 3 years ago, when Microsoft had a phone, they gave it to all the Microsoft employees, and they were pretty much the only people that had it, and it had a fatal text message vulnerability, which they never got to the bottom of. I was very interested. They were walking down the street with my Microsoft friends. They said, "Oh, I got a text," and they said, "Oh, it was the text of death." And I said, "So what?" They said, "Yeah, this keeps happening. Every time you get a text, it reboots your phone, you lose everything, it happens all the time." And I said, "Ooh, that's interesting." But they never got to the bottom of it because nobody used the Microsoft phone and it pretty much went away. But there was something, like I said, whenever it was too long or something, I said, "Ooh, I'd like to see that, but I'd have to get a Microsoft phone and I'm not that interested." So
they're probably giving them away.
Probably. I went to one of these conferences around a year before that, and this guy was up there on stage with a room. I think it was Dave Kennedy was on stage, and there was a room full of people. He said, "I found an attack that will take over the Microsoft phone, but how many people have a Microsoft phone?" Not a single hand goes up, and he said, "Yeah, that's the problem." But I found this attack, and it's pretty cool, but there's anyway. So, all right, you can deface the page, of course. You could add text to it that isn't scripts, just images or something. And you can do this kind of thing. You can put up, "Our business was acquired, please go to our new page." And sometimes people even put up like, "You have to pay a $10 fee now." There was one like this: "Google is now a subscription service. You have to pay $10 a month, but you can get it for only $5 if you sign up by next week. And here's You could put out any amount of code there, and it's just up to your social engineering brilliance to put up something that will motivate people into doing something they shouldn't be doing, like giving you their credit card. You can also add Trojan functionality. You fake login forms on the page, fake buy buttons, that kind of thing. Yeah, this is one from, I guess, 2004, the fake Google page. Selling you Google's going to cost money. So, all right. So session hijacking, where you steal the cookies like I was talking about, is a labor-intensive attack. You put up some kind of, even if you find a stored cross-site scripting, like on eBay, where you can put up a page and it steals everybody's cookie, it sends the cookies to some server, and now you have to like make a session by logging in with those cookies one by one. And you can try to script it, but still, it's quite a lot of work. And if you think about smarter attacks, like Sammy Kamkar's attack did not steal anybody's cookie. He just made them do the action he wanted in their browser right away. No need to steal the cookie, no need to make another session. Much more efficient. So inducing user action is cooler than session hijacking. You just make it automatically do what I want, and then everybody that sees it, it'll happen by the million with no further effort on my part. And MySpace XSS demonstrated, so like I say, there were several attacks that I came by that were really seminal, like when the Jester took down 4 servers for a month from one laptop with Slow Loris attack. That was very interesting. I thought that demonstrated a really powerful attack from a very weak attacker, and demonstrated, really severe asymmetry of the internet. This is why all my classes are structured this way, because I model DEF CON, we teach attack before defense, because the internet greatly favors attack. You don't have to be too smart or too clever or too rich to do an important attack. Defending is very hard.
Didn't Jester also do like a QR code XSS for Twitter?
He put up a QR code, yeah, he put up a QR code that would go to something malicious, and that was one of the other things, yeah, QRs, he claimed to. He also had a lot of fake attacks. He faked a lot of them. But, because his main thing is PSYOPs. He apparently was in the military and he did PSYOPs. And so his whole thing was to rattle the enemy by making it look like he'd done things, so he would cheerfully fake things. Because all of his attacks are psychological in nature, to humiliate the enemy. Then there's trust relationships. Your browsers already trust anything that appears to come from the same website with all the cookies, unless you restrict their subdomain used. You have autocomplete, which will fill in names and passwords and stuff on some sites. And there are trusted sites. And trusted sites can run more code. That was Internet Explorer's security model. So if you can somehow convince it that you're coming from the trusted site domain, then you have more privileges. Especially if you're going to use the old Microsoft technologies like ActiveX and stuff, which has pretty much gone the way of the dodo bird, but it was a wide open door to take over machines like client-side Java for a long time. So ActiveX was very powerful. It was Microsoft's attempt to compete with JavaScript and Java, and it turned out to be far too powerful without enough security controls, and there were a ton of ActiveX attacks back in the days of Windows XP and earlier, but they've pretty much gone away now. I think even Microsoft has abandoned ActiveX. So once you get on the website, you can log keystrokes, capture your browsing history out of your browser, use your browser to port scan the local network. It can try to make URLs local and load pages from them, and specify the port number in the URL so it can send HTTP requests to various services, and you can harvest the results. So, it can be used for a bit of pivoting. And that's what Beef does. You take over the browser and you do some things from inside the browser. It's not as cool as really having a direct command session on a box, but it's pretty cool. You can do anything that JavaScript can do in the browser. And that's enough to get quite a bit of interesting stuff happening. All right, so which attack got a $10,000 prize? Okay, strong webmail. Which one did Sammy do? It made his name. Yeah, it was MySpace. Which one gained administrative access? Apache, good. All right, which one is labor intensive, requiring the attacker to collect and use cookies one by one? That's session hijacking, where you steal the cookies. So let me record this and see if I can find that one. Matt is 2, John E is 2, Jeff is the winner here. Okay, so let me look at my site. I believe I have one of those in all of its glory. Let me see if I can find it. Okay, Stored XSS DOM-based tag attribute value, JavaScript string, URL. These are the fancy ones. Let me see. I may have to...
Because in these reflected attacks, it's running in their browser and then it's sent onto the attacker's site or somewhere for storage where it's collected and replayed, right?
Yeah. So let me see if I can find it. The problem is I can never find anything on my own site. Well, yeah, I've got one, and I think it was even in one of the previous lectures, but I don't know where it is. Might be here. Here. I have to make this thing come to the front. Okay. That's not it. It's somewhere in this mess.
Yeah, let's look for it after class.
Yeah, I guess so. I guess it'll have to be in next class. I've got it, but I can't find it. Anyway, so let's get back to here. We still have some time. We might be able to stay within an hour or so. So you got to deliver these things somehow. So one simple thing is send out a phishing email with a crafted URL or an instant message or code on a website. The watering hole attack is one that China started. They attacked Tibetan groups with this. That's what brought it to attention around 2010. If you want to be more subtle than sending people emails or instant messages, you put up a website that's malicious and you make it interesting. So your target audience will come there. So they put up a page full of like interesting information about Tibetan protest against the Chinese government, and then you just wait, and that page contains malicious scripts and stuff.
Like a honeypot.
That's a honeypot, yeah. You attract them, tempt them in. They call it the watering hole. You poison the water in the watering hole and just wait for them to come drink it. Pretty clever. As long as you're not determined to target one specific person, but it's good enough to target a class of people that are interested in something. Then you can put ads on a page. Just buy ad space or use a stolen credit card to buy an ad, and then a bunch of people will see the ad, and the ad has links to malware in it. You can also target it with keywords to, again, target your chosen audience. Your web apps often have a tell a friend about this site feature, and you can often abuse that to deliver an XSS site. I've wanted these things, you can send an email or send a tweet from a web page, which will then tweet something about the web page. And that means you can create some kind of message that appears to come from that website that contains content somewhat under your control. So now getting the XSS attack to someone, you'll find you can inject code into any place where you deliberately put in data, like fields you fill in on a form, feedback, messages, status updates, anything recorded in logs. You can do, there are quite a few attacks that attack through syslog or through other automatically generated logs. So you send a malformed URL to a web server, it gets logged, it might even be sent to the administrator as an alert, and now you put code, script, real stuff in there and you're attacking those people.
Yeah, especially if they look at
because
logs with the browser.
Yeah, and the logs are shared between users and they're viewed by administrators. So the log is actually a pretty clever place to do stuff. There's some code injection attacks that run code through the logging mechanism. All right, then there's other things that deliver the attack out of band, something like email from the server, where it doesn't go directly by defacing the website, but it still comes from the target company. And like I say, chaining XSS with other vulnerabilities is usually how you really have the big payoff. So here's one, you have XSS that allows you to change your own name, and you can change your name to include script. So now anybody that views your profile can run the script like what Sammy did, that's one thing. But if you find out that if you find a way to change other people's names, you can then put a token stealing XSS in every name and get everybody's token. And then sooner or later you get the administrator's token and then you have everything. So, all right. So the simple approach is you stick in some kind of script tag, you inject it everywhere and see where these things pop up. That's how you typically do it by hand. That won't find them all though, because some injections need a different format, like SQL injections. If you have blacklist filters that are removing script or less than or greater than signs or quotes, then that won't work anymore. So you're going to have carefully crafted attacks where you change uppercase to lowercase. You use other things besides less than and greater than, encode it. You put script inside script, so when it removes one, it'll still have a script left. There are various ways to mangle it, to fool it. And there may be cross-site scripting attacks that don't just simply echo exactly what comes in. It gets sanitized or decoded or something. In DOM-based XSS, for example, something in the URL bar appears on the page, but it might be modified somewhat. So you come up with a benign string, inject it everywhere with a script, and just look for that anywhere on the page. And so when you do, then you'll have a clue. This is how essentially an automated vuln scanner would go, and you can write your own, and I would imagine that Burp has some ability to do this in the professional version. So you have a unique string like that, my XSS test and some random letters submitted everywhere, and just monitor all the responses for appearance of that string. Burp does have that feature, by the way, and I've been using it in my tests. If you go to Burp and you go to history, and you're looking here and you think that some response here might have like Sam in it, you can search here, and then you can just see the 0 matches. I've done this quite a bit when I'm hunting for things. You can just go down here really fast and see there was one there. It'll pop up in the corner with color, so then you can go back. So you could totally inject some weird word and quickly scan through all the responses right here to see if that word came back to you. And that would be a clue that that thing is probably vulnerable. All right, then you're going to have to manually test it to see if it's exploitable, because it might be mangled or filtered or something. And so let's take a look at some of these. Here's some examples of situations where you have to be a little more careful what you inject. So why is this thing not shrinking? There we go. All right. So let me go to my XSS demos and try to move this so that is not in the way. All right. All right. So it's 5, I think. Yeah, let's look at 5. All right. So you have an image resizer, height 50% and width 50%. So when I submit it, my image is shrunk by 50%. And that is actually putting these things, let me go there and let's look at what it did. If you look at the source code and blow it up, that should, where we are. Okay, what I put in ended up in here, which means it's inside an image tag, inside these less than and greater than signs, inside an apostrophe. If I want to inject stuff, if I try to put the normal kind of injection in there, it's not going to work. Let's try that. If I go here and I put in script, alert, 1, script, I don't think this is going to work. That's the typical kind of injection. And this is City College Network blocking it on the network, because that looks like an evil cross-site scripting attack. So I'm going to need to go through my phone or something to do it. Is it my phone or my iPad that has the ability? I think my phone has the ability to give me unfiltered internet. In the lab, I've got a danger zone for this reason. Let me see if I've got the ability to go away. Yelp is asking me something. Get lost, I don't care. Phone's loaded to pop up some irritating thing to ask me a question when I don't care. Anyway, like everybody always says, do you want to do updates? And I'm like, go to hell. I'm at work. I don't even want to think about your sneaking updates.
Especially on an iPhone.
Yeah, especially on an iPhone, but really anytime. I'm trying to get work done. Don't ask me stupid questions right now. Of course, there's never a good time to ask me. So anyway, all right, now I'm supposedly connected. So let's see what happens now. There we are, unfiltered internet. So I can see what happened, and you see the script is there, but it won't run because it's between the quotes and treated as literal text. So all it has done is add that to this, which is now an invalid height parameter, so it will just default to the default height. So that is not how you inject in this. What you have to do is have a more careful injection. And in this case, you got to finish the percentage and close it, and then put it here. That you got to realize where it's being injected. This is very much like SQL injection. You have to close the apostrophe and close the greater than sign so that it completes it, and now it's outside, so it'll run. And then you have some leftover junk here because I didn't bother to have extra quotes and apostrophes to make it balance. Now, if it was SQL injection, it would stop and say syntax error, but HTML never does that, which is why it's so vulnerable. All browsing pages are, in fact, rendered even when they have errors. That's just the way browsers have been by tradition. So it makes our life a lot easier. And I would view the source code if I could figure out how. Why could I do it before and I can't do it now? Right click. Oh, because something's selected. Okay, there we are. view source. All right. So here you can see, now this tag closes, and that stuff now runs, and this is just leftover junk. So you have to consider the context to figure out what kind of injection would work. All right. And down here, for example, I've got a JavaScript string. So I put it in foo, I submit it. Now I get a page which has foo up there, but I don't think it's using foo. If I view the page source, script var a, well, it determines a variable, but it doesn't print that variable. Okay, so you put in something, it's used in a variable for some other purpose. It might be your name for a game or something, but your name doesn't directly appear on the page. It's stored inside JavaScript, so you're going to have to inject script to use it. Or you're going to have to break out of that definition page with something like this. Again, you want to end it. Let's try that one. If I do that, now I'm going to get the alert again because view page source, I say. All right, come on, view page source. Okay. Because now it defined the variable, and this is what I fed it as a variable. Or I guess that is what I fed it as a variable. We'll call it SQL injection. So I finished this one, and now I have a code to run. There's lots of ways to do it. You could also let it define the variable and then write JavaScript that uses the variable, like puts it on the page. The sky's the limit. Here you might have a URL you're putting in, and it's used in the URL. So now if I click here, it'll go to City College. Okay. So if I view this page, this is what I control, and again, it's inside a tag, inside apostrophes. So if I want to exploit it, I have to customize the exploit to fit there. There are various ways to do it. One is to use the URL the way it is. You can put a method in front of the URL. I forget the name of these things. These things before the colon, like HTTP and HTTPS. There are a lot of others. You can just run JavaScript directly in the URL. You can just put it right up here in the browser and run it. Or you can just use the fact that you can close this, and then you can make a parameter here. For example, you can make an on-click. Forget what they call these things too, but they're these things you put inside HTML which run JavaScript. And they are not in script tags, and somehow I failed to get view source again. Okay, there. These things here are called handlers or something like that, where when you click it, it will run JavaScript. I've forgotten the technical term for these things, but that's one way to run JavaScript without putting something inside script tags.
So as in when you click the href, it will
Yes.
run it? Okay.
And you can also have one in the body tag that will happen when the page is loaded, and you could have ones that on mouse over, when the mouse goes over it, they run. You can do all kinds of things. And what's funny is they are part of the whole unsanitary web thing. This is not HTML. It is not a recognized part of the anchor tag. So the HTML parser sees this, does not understand it, and ignores it. And then the JavaScript parser finds it. And that's the way the whole web is built, with these weird documents that mix multiple languages in the same file and are passed through multiple times by different parsers hunting for what they can find. And that's the recipe for disaster. The original theory 20 years ago of computer programming is you should have one file for one purpose. You should have a C source code, and there isn't any Java in there. It's all C. If you want to write Java, that's in a different source code. It's compiled. You never have two different things in the same file. And everyone was really mad at Microsoft for putting Microsoft Office 2010 documents that would have Visual Basic Script in the Word document file. And they said, you're polluting the internet with your horrible stuff, but the internet was thoroughly polluted by all this. And you've even got stuff here that's run on the server side, like PHP, and stuff run on the client side, like JavaScript, and all this stuff mixed in one file. And that's the way the whole internet is, and there's no going back. Anyway, all right, there's a few of those. The URL, so you can probe your defensive filters. Your application probably has some defenses these days. As you see, my browser has defenses, and the City College network has defenses. Oh, I feel stupid. I didn't have to go through my phone. I have a defense. I have an attack to get through the City College network, and I don't know how I failed. This should not be going to AD. I went to the wrong URL here somehow. This should be going to games. That's why I did this. There.
Whitelist.
HTTPS. No, it's HTTPS. And we we do not man in the middle HTTPS, so all the City College filters can't see anything I do anymore. So I found this my simple circumvention. This is why the City College has blocked my website several times, and I've never bothered to ask them not to, because it's always turned out I can just tell my students what to do or modify my web page. They blocked my domain at one time, so when you clicked anything from my homepage, it wouldn't go there, so I just put hard-coded URL IP addresses on that page, and that got past that. Anyway, so now I won't be bothered by City College's filtering anymore. If you're looking for signature-based filters, for example, here's an anti-XSS filter, just what I just saw from the City College network. A potentially dangerous request was detected. Many devices are looking for obvious XSS SQL injection and things like that. So if you do, just try removing parts of the string until it goes away, then you can probe to find out what it detected. Was it script or what was it? And then once you figured out what part of it triggered that defense, you can then play with modifying it to sneak it through. And it's really usually quite easy. So if script is blocked, try base64 encoding script. This tag will let you put base64, which will decode into script. Here's another way to do it. That's one way. Base64 is perfectly valid on the web if you put it in correctly. Here's some examples of ones that work with the base64 in them. I don't think I'll bother doing them, but it's easy enough. Here's some event handlers. That's what they call these things, event handlers. On ready state change, on error, all these things, on focus in when the mouse goes over, when you tab to make it the active element, on ready state change, all these things will happen at certain times. And these are all ways to run JavaScript without putting up a script tag. You put up something that just looks like another HTML parameter, HTML attribute. An autofocus is here. This will run on focus, and this will automatically focus here when the page loads. So the end result is it'll happen as soon as the page loads. This is on blur. Blur is what happens when you're no longer focusing on an object. Like, you can surf the web without a mouse. You can go tab, tab, tab to highlight the button and then push enter to hit the button. So blur is when you leave focus. So that's the game. On scroll, when people scroll the page, it'll happen. And on you go. There's just lots of things you can do on error, on mouse over. There are pseudo-protocols, where you put in JavaScript, like we talked about before. Any place you have a HTTP, you could put in JavaScript instead and just put code right up there. IE used to allow the VBS protocols. You can just put Visual Basic code right in the URL. It's like the Visual Basic was Microsoft's competitor for JavaScript. HTML5 gives you a few more ways to insert JavaScript into URLs and pages. IE7 used to allow this, a style that would then have a JavaScript inside the style. Later IE allows this weird stuff. That's why, if you want to think of the job of someone making a web application firewall, you're supposed to detect all this. Good luck. That's why they say whitelisting is the way to go. You should, after it's all over, take whatever's really going in and see if it's evil. Don't try to get all the things which might turn into something evil in translation. Anyway, so you can put null bytes in. The thing about null bytes is they will stop C-based handlers, and it is very likely that the web application firewall or the defense turned this into a C string to examine it, so it'll terminate here, so it will never see beyond this point. But the web application will interpret it as %00, and it will not terminate the string for the processing of the web app. So the filter doesn't see it, but the web app sees it, and that's what you want. You sneak your stuff through. And that's how it works. And that's because your web application firewall has to run fast. It has to handle all the data coming in, so it can't be using web languages like JavaScript. It's got to be using a different language, and that's typically C. Then you can have invalid tags, like source in an X tag. There is no X tag. So, and remember, I said this before, this is the problem with the web. Browsers will not balk at something they don't recognize. They will just ignore it, because they'll say, I must be an old version of browser. There's probably some X tag in whatever language they're using, or this is some goofy other language like PHP or something with an X tag. I'll just ignore everything I don't know about. And so it gets through. The filter may not see it. And you can hijack base tags. There are ways to change the base of an entire page, the base URL, so all the relative URLs on the page refer to there. And if you do that, you move the whole page to effectively to a different site. This is also, you can also just reload JavaScript functions from a second server. If you load another JavaScript function with the same name as one that's already in use, the new one takes priority, and now the malicious things happen using the name the developer specified. Just like we did before with HTTP parameter pollution. You have a parameter that says admin equals 0. I can just add another one later that says admin equals 1. And it will often fall for that. You can put spaces after the tag name. Often people look for the tag, so you have to inject things without spaces. I was doing this in a training product last week. There's a lot of ways to get by without spaces. You can put in a tab here, a slash, parentheses around things. You can make almost anything happen without using spaces. Any kind of punctuation mark like these will do it. You can also add extra tags where there be no space. You can also put comments in the middle of tags, and they'll be ignored, but they'll mess up the filter. You can put null bytes in an attribute name. You can use in IE, you can delimit things with a quote, an apostrophe, or a backtick. But the people that write web application firewalls don't always know that. And if they don't, then it won't interpret this as a delimiter. It will interpret it as all part of the source. So it won't recognize this as malicious JavaScript. But the server will interpret this as the delimiter and that as the parameter. You also don't really need to put in delimiters in HTML. You can just put ahref equals http://yahoo.com with no quotes, and it works. The quotes are optional. If you just try stuff, a lot of defective HTML is accepted by browsers. And that follows up the filters that are just looking for the standard configuration of it. You can put characters, encode characters inside this alert so that it's no longer recognized as alert by the filter that's trying to find it. And you can do HTML encoding any of the pages here. Just use the ampersand pound and then a number, pound X, to have any hexadecimal number to specify any character you want. And that will follow up the thing in the middle. And remember, it is quite common that you have 2 layers of decoding because some firewall decodes it to try to prevent the previous attack, and then the web app decodes it again because it doesn't know that the firewall has already done it, so you can just doubly encode. The %25 will decode to a %, and then you'll have %3C. All right, and here's another one. You can often use malformed Unicode, and it will clean it up. So you can often use the wrong character and it will take it. Like this is not a less than sign, but it kind of looks like one. And some browsers will accept it. And some app frameworks will accept it. You can put in extra brackets and browsers will accept it. Firefox will let you use these weird curly brace things for some ungodly reason. Because remember, the mandate for the people that write browsers is horrible. They say, render code, and if the code is broken, do the best you can to render it anyway. Because so the people that make it just sort of guess at what kind of horrible stuff am I going to have to render. And there are companies like Yahoo that are famous for this. They write horrible HTML. They don't care. They polluted the web with 1 billion pages of poorly written HTML. And if the user can't browse Yahoo, they feel like your browser is no good, so you have to make your browser tolerate all the weird stuff they've done. So there's a thing called the Web Developer Add-on, and this will show you what happens to the HTML after Firefox tries to fix it. So you can see at least what Firefox does. It takes web, it changes characters and moves things around to try to sanitize the code, and this is one way you can see what it's done. There are a lot of different character sets. UTF-7 is like the closest to ASCII. Here's the American ASCII. UTF-7 is 7 bits. UTF-16 is 16 bits. This is what Microsoft uses a lot. And you'll see this in your Wireshark and such, the characters separated by nulls because it's an international language. And it specifies a width of characters of 16 bits, not 8, so that it can smoothly handle Japanese and Chinese and German and everything. So you can tell your browser the character set. There are several tags you're supposed to have at the top of every page, like telling it what character set you're using. People often don't, but you're supposed to. You can set it in the HTML source page. This one's pretty awesome. This is a Japanese system. Now, as you may know, Japanese language is incredibly complicated. There are like 60,000 characters or something. And so there are two different layers of simplified languages. And one of them is kanji or something. So one of them will fit in 16 bits. And it's what's used to print newspapers and stuff. But it takes 2 bytes to make a code. So what you can do, this is really awful. So suppose I have image name here that came, here I have alt equals something came from the user, and down here I have something else that came from the user. This one will not let me put in a quote, so I can't escape the quote. This one will not let me put in less than or greater than, so I can't put in an HTML tag. Well, that means I need to get rid of this quote, but I'm not allowed to put in another quote to break it. So what you do is you put in this %F0, that begins a 16-byte Japanese character. And it eats up the next character the developer put there to finish it. So I can suck code out of the source code the developer put there and remove it. That's pretty awesome. I love that. I can backspace out your code with my injected code. Anyway, so here's Unicode, putting a character in the middle. This is an L. You can use eval. This is the evaluation function that will evaluate code it sees there. You can put in escape characters before harmless characters like L and E, and they don't do anything, but they make it not fit the pattern anymore, where the filter's trying to block it. This one took me a while to understand, and this is where you have to, one rule about Microsoft is all the names mean the opposite of what they should, and this is an example of how that happens. So you can put base64 in your source code, and there are functions in JavaScript to handle that. So put this in your pipe and smoke it. This is base64 or something like script alert1/script. So this is what they call ASCII. And when it's decoded, they call that binary. Now a person might think it's ASCII the other way, but the point is this all came from the old days of UU encode and UU decode. When you have this binary data like images and you want to email them, you have to turn them into something that will fit in an ASCII only system like email. So you have base64 encoding that does that. So they call this the ASCII. So they call this ASCII to binary to change that into this. And this function exists. But anyway, that means, again, you can put base64 in your code and run it through the A to B JavaScript function to turn it back into something else. And how in the world is your filter ever going to detect that? So I've got that one running here in my demonstrations. Because I was sort of baffled. Well, one of these that's coming up kind of baffled me. But there's base64 encoding. I thought I had another one. Maybe I've lost it somehow. Ah, there it is. I just had to refresh. This is, okay, we'll get to this one. That eval one was so bizarre I had to build it. I couldn't believe it. All right. Yeah, this is the one. So you eval A to B of that. This whole thing will then turn into some script. Good luck with your web application firewall figuring that out. But here's alternatives to eval. Now eval is one of those really dangerous functions that a person might block. So you can do this. This one kind of gave me a headache. I've got a script here. I got alert1. Now this is a string. I'm going to run the replace method. The replace method is going to, this dot plus is the arbitrary, it's the regular expression for any series of characters. So it's going to replace any series of characters with eval. So when you try this with a non-eval word, like face, it will take whatever's here and replace it with face. But when you replace it with eval, it runs eval instead of replacing it. And I couldn't believe that was true, so I coded it to see, and it's true, and I really don't understand why. But here it is. Here's the source code. Like I went to one of those demonstration sites where you can modify source code. So here's the source code. I have a paragraph named demo up here. Here's the live alert, and that's just sitting there. But I have a button you can click, and when you click the button, it runs this script, and the script runs string replace eval on that field. And so when I take this and replace it by eval, it runs that script. You'd have to look into it more than I have to understand why, but it works. That is mighty screwy. But anyway, this is why, blocking this stuff is pretty heroic. There are so many convoluted ways to run script. Anyway, so you have multiple techniques where you use a backslash URL encoded, and then you have HTML encoding, and you make some horrible garbled mess of characters that adds up to your script, and how in the world is anybody supposed to recognize that in a filter? There's a whole section on VBScript injection, but that's pretty much over. Microsoft has abandoned VBScript, like so many of their other products like Silverlight and many other things. Microsoft is real good at that.
How long did the Silverlight live? 2 years?
I don't know. If Silverlight was like their Windows Phone, they begged developers to please develop and put it in the store, and everyone said, I'm going to write for the iPhone, dude. That's where the money is. Anyway, you can encode characters like this. If you want to protect yourself from this junk, you encode special characters to HTML encoding so they won't be accepted as delimiters. Check to see what's sanitized, and try to make sure you can not make an attack string with whatever is still allowed, and try to sneak in script various ways and see if you can get in. Here's common mistakes. You run one test replacing script, but you don't make it global. So if I just put in 2, one of them gets through. You're not recursive. So if I remove script and what's left still has script, you don't go again and keep looping until there's no more scripts in there. So then this kind of thing will get through. You could also have stages. So I have a loop that removes all occurrences of script, and then I have a loop that removes all occurrences of object. So all I have to do is put in something that has object, so there's no script in it, but when you remove the object, the script appears. And you don't go back and do another round of script. I don't know when. I just have to defeat your logic. You can inject into an event handler. Here's one that does it, which would run in some handlers where onClick equals a variable is foo, and you can hide things inside places where they really shouldn't run, but some browsers will run them. Because remember, the problem is, this is just like you have a translator, and someone is talking some garbled, broken language, and you have a translator trying to translate it into English and trying to guess what they meant. I've seen plenty of comedy movies where they have someone translating who's got their own agenda and they're modifying what they're saying. And your browser is doing that. It's taking this garbage and trying to figure out what it was supposed to be and how to fix it. And so often it will turn it back into executable code. If you have another thing, if you have length limits, you can just try to make your attacks very short. There is a language called JSFuck, based on brainfuck, which is the opposite. It makes everything JavaScript. It's all punctuation marks. I did it in a CTF. There was an injection code that was 65,000 bytes long, and it printed like one 10-letter word. You can write JavaScript with nothing but punctuation marks, semicolons and brackets and parentheses. And with thousands of them, it can add up to things. So they call it JSFuck. If you Google it, there's a JSFuck interpreter, and it's incredibly hard to understand, but you can make whole working things that have JavaScript without a single ASCII character in it that you can read, just semicolons and parentheses and square brackets. And this is the opposite. You can also decide to try to make JavaScript really small. And so you can do weird things like this. This will connect to the server named A because this is a Microsoft path, a UNC path they call it. / server name / connects to the server. You can do it with forward slashes. This will connect to the server named A and send the cookie to it in a very small request. And here's something I mentioned before. You do not need the delimiters. You can just put HTTP. You can just put A there without the .com or anything, and it will go to the local server named A. Here's a Packer online to make your JavaScript super small. So it can't do much with this. It's going to stay the same size, but if you have a more complicated JavaScript, it'll make it smaller. This is what people use to make their pages load faster, and they also use it to stop other people from stealing their code, other developers, to just obfuscate stuff. So you can inject code where part of it goes here and part of it goes there. We have 2 injection points. And we've done this with XML injection before. So if I want to, I have 3 hidden fields, and I'm going to inject a little bit into each one. I can inject the script tag here, then start a comment tag, comment this stuff out, put the alert tag here. By injecting these comment tags, I can piece together things, skip the part in the middle that I don't control, and build what I want, chunk by chunk. I have a script, then the comment starts, none of this stuff matters. Then in the next one I have this, so I've got 3 lines. There's supposed to be 3 separate tags, but by commenting out large portions of it, I build the tag I want. You can inject JavaScript. This thing called #slice will create DOM-based XSS because it will insert the code that came from the URL. The slice is also called the fragment. It's the part of the URL after the pound sign. So you can inject JavaScript that creates that. This will convert reflected to DOM. All right. This one here is kind of baffling. The eval and unescape and all that jazz to get the location. Again, harvesting things from the URL and putting them on the page. Creating DOM-based XSS. And you know, the sky's the limit. And if you look at, say, Arsnake's blog, he's got a ton of these cool attacks. They come by all the time. All right, so which one puts a malicious page up and then waits for users to find it? I like it, very subtle. And it's hard to think of a defense. There's nothing in your IDS.
Is this what Cambridge Analytica ended up doing with social engineering?
Well, sort of. They put up a game and then get you to play it.
Yeah. And then they...
Yeah. Although they actually, I think, paid some people to play the game.
Yeah.
But you could, a lot of people do have these, like, one thing that's really common is make your porn star name, take the name of your dog and put the name of your first house in it. They're getting your secrets that way. There's a bunch of these games that leak things you shouldn't be leaking out.
But I'm saying that they took the targeted information,
Yeah.
crafted a message for these people that they would be attracted to. But I don't know how they got them to go
I don't
there.
think they did. I think they paid people. They actually paid like 100,000 people to take their survey.
Okay.
And then, if they had, by Facebook's rules, all their friends, they could harvest their data too. That's how they got all the people.
But I'm saying they actually made websites that defamed Hillary and did all this.
Oh, that's-
They got them to go to them.
Yes, that's true.
That's the watering hole.
Yes, that's right. That's the watering hole.
Convince them.
And that's what Russia did, yeah.
Yeah.
By very carefully crafting messages that will have the desired effect and be shared by people.
Yeah.
And that's how we made the stations, how we made the American Revolution, by fake social media accounts of the day from Ben Franklin and Thomas Paine pretending to be a bunch of people angry at Britain, carefully posting inflammatory messages to make everyone think there was a big movement of people angry at Britain, which there was not. So it's not like this is anything new. It just happens faster on the internet. Anyway, so which attack puts the first part of a 16-bit character on the page so I can suck away a character the developer put there? This is just mind-blowing the more I think about this. Suppose I could take my red pen and cross out some of your source code. What fun. That's Shift-JIS. So what character causes a filter to stop, but the script still goes through? This is what's wrong with ActiveX controls. ActiveX controls just had a bit you could change called trusted or harmless. So you could just say, oh no, don't examine this ActiveX, this one's fine. Anyway, that's the 0. The null character will stop the filter, but it won't stop the browser. And so which function will decode script written in base 64? That's ASCII to binary in the language of the 70s. Anyway. All right. I will go to the lab, clean up here, and just go to see if anybody wants help in the lab. The last quiz is up, due next week. We're rapidly coming to the end of days here. There's, I think, 2 more classes, and that's it. Then there's a couple of canceled classes because I'll be in China, and there's a final that's just online. So only a couple more classes. I will see you here.